Hey folks, I wanted to, I put this stuff in there. I know it's a lot of words, but it's definitely some stuff that we want to go through. Okay? And I'm just going to read through it and kind of talk about it. It says you can eliminate the radical from the denominator by multiplying a radical expression by an appropriate value of 1. Now let me show you what that means. If I had the square root of 5 over the square root of 7, you see I've got this radical in the denominator, Ryan? This is what we were talking about just a second ago. I don't like it. Okay, it's easier to work with it being just an integer. So I'm going to multiply this fraction by root 7 over root 7. Do you see that root 7 divided by root 7, it's 1, right? Okay? Exactly. I'm not changing its value because this is equal to 1. Right? Root 7 divided by root 7 is 1. But it changes the way it appears. So I'm going to get root 35 on the top, and I'm going to get 7 on the bottom. Okay, now that's a lot easier to deal with. Okay? The process of expressing this as root 35 over 7 is called rationalizing the denominator. When we get rid of the radical in the denominator, that term is called rationalizing the denominator. Okay? As you can see, it is easier to name the decimal value of root 35 divided by 7 than root 5 over 7. Now, we have a calculator, so it's easy for us to do it. But when we're putting fractions with radicals together, it's easier for us to work with integer denominators. Okay? So we've got to get those common denominators together. Yeah, welcome.
Can you just multiply the denominator with that number under the radical and top?
Wait, multiply the numerator by the... I'm just multiplying whatever number, whatever is under the radical in the denominator, that's what I'm going to multiply the top and bottom by.
So you don't have to like write all that and
Well, no, they're showing you what's happening here.
Okay.
Okay? Now, it says, an expression having a square root radical is in its simplest form when? Okay? We talked about simplifying these things. This is when we know it is simplified. No integral radicand has a perfect square factor other than 1. What does that mean? Here's what it means. Like the square of 27, all right? This has a perfect square factor in it. It's root 3 times root 9. Do you see root 9 is a perfect square? Okay, so this is not simplified. 3 root 3 is its simplified form. That's what number 1 is talking about. No number under the radical has a perfect square root factor. Okay, we've been doing that all along. Number 2 says no fractions are under a radical sign. So this is not simplified, right? We need to write it like this. Root 5 over root 7. But then we go to number 3. No radicals are in the denominator. Okay. Multiply by root 7 times root 7. That gives us root 35 over 7. Now that is simplified. Okay. We don't have any fractions under a radical sign. We're going to have to simplify that one. Okay. And we don't have any radicals in the denominator. We're going to have to simplify that one. Okay. Now, let me get rid of this stuff. We'll scoot down and start working on these. I probably won't be able to finish these all before this video, so we may have to do 2 videos here. Okay, there we go. All right. Now, what's the problem with A here? Coolis?
There's a radical in the denominator.
Exactly. So we're going to take 3 over root 5, and we're going to multiply it by root 5 over root 5. Because I just want to get 5 out from under the radical. Okay. Can I multiply 3 by root 5? I mean, can I make it root 15? No. So I'm just going to write it as 3 root 5. Can I simplify the root 5 up here in the numerator, Boyd? Is there anything I can pull out of it? It's as much as it can be, right? But what do I get on the bottom, Boyd? Root 5 times root 5. What is that?
5.
Done. Simplify. That's A. Okay? Now I'm going to erase it in just a minute. But those on the video, they can just pause it if you want to look at it. All right. Now we're going to go into the next video, and I'll finish up the other 3. Good job, guys.
If you have
Who was that that
Missed
came?
it.